Welcome to the distance formula day 2. If you remember from day 1, we talked about using the Pythagorean theorem to figure out the distance between 2 points on the coordinate plane, creating the right triangle, drawing in the legs, and then ultimately solving for the hypotenuse. And if you take a look at the Pythagorean theorem, c squared equals a squared plus b squared, we talked about really how the a value in our triangle was taking the x's and subtracting them, and finding the b value was taking the y values and subtracting them. And so the last step to figuring out the distance between the 2 points is to take the square root of both sides of the equation. This is what brings us to the distance formula. From the previous problem, we now have this distance formula that'll help us to calculate the distance between any 2 points given the 2 ordered pairs. And so we change the c for the hypotenuse to d to represent distance, and that's equal to the square root of the entire quantity x2 minus x1 or x1 minus x2, that quantity squared, plus y2 minus y1, that quantity squared. And so now we can just simply plug in our x-coordinates and our y-coordinates and figure out the distance without having to use the coordinate plane, which will help for points that are really far apart. Let's go ahead and take a look at example 1. With this example, we're going to show the distance between the 2 points is the same whether we use the Pythagorean theorem or this newly established distance formula. You can see I've plotted the points -4, -6, and 1, 4. I drew in the legs to form the right triangle, and I've counted the units for the side lengths 5 and 10 in order to figure out the hypotenuse or the distance between the 2 points. So from here we can plug in the values we know. C squared equals 5 squared plus 10 squared. Doing some math on our calculators or in our heads, c squared equals 25 plus 100. If we combine those two, we get c squared equals 125. And last but not least, we take the square root of both sides and get c is about 11.1 units. For the distance formula, we need to establish what are the x values in the ordered pairs and what are the y values. And so looking at the ordered pairs, we have the -4 is our x value, as is the 1. And because it's the first ordered pair, I'm going to put x1 above the -4 and x2 above the 1. Similarly, my y-coordinates are the -6 and the 4. And again, the first ordered pair, y1 for -6, y2 for 4. And now we set up the distance formula. So we have d equals the square root of x2 minus x1, or you could do x1 minus x2, plus y2 minus y1, or again you could do y1 minus y2. From here we can substitute in the values that we just labeled. So we have 1 minus a -4 squared, and we have 4 minus a -6 squared. And from here it's simplifying. So distance equals, if we have 1 minus a -4, that's really adding a +4, and so we'll get 5 squared inside the square root. Similarly, 4 minus a -6 we'll get is adding a +6, and so we'll have 10 squared. You should notice that these values are very similar here if I am looking at the Pythagorean theorem setup and if I'm looking at the distance formula setup. They're meant to be the same. We're using the same idea. And so from here, I can go ahead and say distance is equal to the square root of 25 plus 100, which is square root of 125. Again, we have the same work when we use the Pythagorean theorem. And then, I can approximate my distance to be about 11.1 units. And so, regardless of the approach, I've found that the distance between the 2 points is 11.1 units. And now we can use the distance formula, especially for these points that may be far apart. Let's go ahead and try example 2. I've given myself a little bit of a head start on this example by writing out the distance formula, but let's go ahead and start it like the previous problem. Let's identify our x's, x1 and x2 for the first and second ordered pairs. Similarly, y1 is 6 and y2 is 14. And so when I want to do x2 minus x1, I'm going to take the x2 value of 18 minus 12 for the x1 plus y2 minus y1, so 14 minus 6, both of those quantities squared. From here, it's using the order of operations to simplify, so I'm going to go ahead and subtract inside the parentheses first. I'll get 6 squared plus 8 squared. From here, I need to simplify the exponents, so 6 squared is 36 plus 64. I get distance is equal to the square root of 100, which we know to be 10 10 units. And so that's the distance between the two given points. No graph was needed, no Pythagorean theorem. Go ahead and pause the video, try example 2, letter B out on your own, and then when you're ready to check your work, press play and see how it compares. The distance formula is set up. If you identified your x's correctly, you need to subtract 7 and negative 4. If you identified your y's correctly, you need to subtract negative 3 and 1. Please be sure that when you go ahead and subtract them, that you do keep them in parentheses, so that when you square them, you get positive numbers. You should only have positive numbers that you're adding together. And then the distance is equal to the square root of 137, or about 11.7 units. And that concludes your introduction to the distance formula.